We're moving on from the law of sines. Law of sines was a fairly easy formula. Law of cosines, slightly more complicated. So we have a triangle. The law of cosines, like the law of sines, can be used in any triangle whatsoever. We are not limited to right triangles. This will look similar to the Pythagorean theorem. Similar to, because it can't be exactly the Pythagorean theorem, as that applies only in right triangles. The idea here, c squared is a squared plus b squared minus 2ab times the cosine of angle C. Wow. This part right here looks exactly like Pythagorean theorem, but then you must add this part on, the minus 2ab cosine of angle C. You could write this formula for any of the three sides of the triangle. So we could say b squared is a squared plus c squared minus 2ac times the cosine of angle B. The third one could be a squared equals b squared plus c squared minus 2bc cosine of A. So, the formula, unlike law of sines, this one's a little bit more difficult to remember, but the idea, if we're looking for side A, this side right here, it's going to be b squared plus c squared minus 2bc times the cosine of A. The right side of the formula will be a pair of sides and the angle between them. Always. So, this is not a multiple choice question, obviously. The shape of a piece of property is triangular with an 85-degree angle between two sides of 1.2 and 2.4 miles. What is the approximate length of the third side? So this is 85 degrees. We have 1.2 miles. We have 2.4 miles. We are looking for the length of the opposite side here. The law of cosine says we have x squared equals 1.2 squared plus 2.4 squared minus 2 times 1.2 times 2.4 times the cosine of 85. So when you do a problem like this, plug all of this in the calculator, you get 6.7. If you make sure and write the problem out in complete steps like this, it should obviously stick out to you that 6.7 is x squared, and you need to take the square root. People will answer this question with 6.7 often because they forget about the square root. Make sure you don't do that. Try and remember the square root as best you can. This problem is where people start to make a little bit more in the way of algebra mistakes, or primarily plug it in the calculator mistakes. We want the measure of angle C. By the law of cosines, we have to set this up. Since we're looking for angle C, we start with the 14, the side opposite. 14 squared is 6 squared plus 9 squared minus 2 times 6 times 9 times the cosine of whatever the measure of angle C is. The next step here, algebraically, is to subtract the 6 squared and subtract the 9 squared from each side. Like this. Boom. This is where the first algebra mistake tends to happen, and this one I think gets caused mainly by people trying to go too quickly. People see a negative sign, and so to move this number over, they tend to add. But what is the mathematical operation occurring here? It's multiplication. So to move that, we have to divide. So we get 14 squared minus 6 squared minus 9 squared all over negative 2 times 6 times 9. That equals the cosine of angle C. The last algebraic step tells us that the measure of angle C, right here, take the inverse cosine on each side. So it's the inverse cosine of 14 squared minus 6 squared minus 9 squared all over negative 2 times 6 times 9. So There are going to be some algebra mistakes that tend to occur here, but then at this point, plugging all of that in the calculator correctly can be a problem. If you want to put that all on one line in the calculator, it's going to look like this. Inverse cosine of, in parentheses, 14 squared minus 6 squared minus 9 squared. Because the numerator has to be in parentheses by order of operations. Divided by, in parentheses, negative 2 times 6 times 9. That is what you have to put in. When you put that in the calculator, what do you get? Nearest tenth, 137 degrees. Okay? So in a problem like this, unfortunately what happens a lot is that people just put it in the calculator incorrectly. And obviously if you do everything correctly except put it in the calculator, you're not going to get the right answer. So make sure you're getting good practice at doing that. This problem presents a different little challenge. But the first step is to draw the picture. A, B, C. We know side B is 4.4. We know side C is 7.6. And we know that the measure of angle A is 51 degrees. They want the measure of angle B to the nearest degree. We do not have enough information to figure that out. We do have enough information to figure out side A using the law of cosines. A squared is 4.4 squared plus 7.6 squared minus 2 times 4.4 times 7.6 times the cosine of 51. Because we know these two sides and the included angle, law of cosines then will give us the length of the side opposite that 51 degree angle. A is 5.9. We were not provided a unit of measure here. So, now at this point we have enough information to figure out the measure of angle B. We could use the law of cosines to figure it out. That's valid. But a shorter method would be to use what? The law of sines. We cannot use SOHCAHTOA here. Why not?
It's not a right triangle.
Because it's not a right triangle, we can't use SOHCAHTOA. But we can use law of sines. So we say sine of B over 4.4 should equal sine of 51 over 5.9. So anytime you're working in a triangle, once you've done law of cosines one time, you should be able to use law of sines for everything else. You could still use law of cosines if you'd like, but you don't have to. But we set it up with law of sines. With that, what is the measure of angle B rounded to the nearest degree? Measure of angle B, 35 degrees. Boom.
That's what they score.